In this video, we'll review the rules for exponents. Now this is going to be a long video, so I'm going to go pretty quick here. So these rules that are on the screen right now, these are the ones that you should know by the end of this video. Alright, to begin, let's begin with the 0th power. Any number raised to the 0 power, with the exception of 0 to the 0, so any non-zero number a raised to the 0 is an automatic 1. Again, you can't do 0 to the 0 because that's undefined. So let's look at 3 examples. 15 to the 0, the quantity -4 to the 0, and the quantity 1/4 raised to the 0 all have the same value. Any number, with the exception of 0, raised to the 0 is an automatic 1. The next rule is negative exponents. For every non-zero number a with an integer n, so a to the negative n can be rewritten as 1 over a to the n. Any negative exponent needs to be rewritten. Now you can't do 0 to the negative exponent. Anything 0 raised to a negative exponent is again undefined. Here's a couple examples. 5 to the negative 2 can be rewritten. This becomes 1 over 5 squared. 5 squared is 25, so it's really 1/25. Try the next two. 2 to the negative 2 becomes 1 over 2 squared. 2 squared is 4, so it becomes 1/4. 2 to the negative 3 becomes 1 over 2 to the 3rd, or 1/8. Let's try a little bit harder one. Here we've got 6x squared y to the negative 3rd. Only the piece that has a negative exponent needs to move. The 6 has no exponent, so that's not going to move. X squared has a positive exponent. Only y to the negative 3 has the negative exponent. So the 6x squared is going to stay, but the y to the 3rd goes to the bottom. Here's another one. Negative 4x to the negative 5th times y to the 4th. Only x to the negative 5 has the negative exponent. The negative 4 and the y to the 4th stay. X to the 5th goes to the bottom. Again, only the piece that has the negative exponent moves. Now that negative 4 is not going to move because that's not an exponent, that's a coefficient. You can have negative coefficients. But what if the bottom number is already negative exponent? What if the negative exponent's on the bottom? In which case you got something like 1 over z to the negative 4. I can't move it to the bottom because it's already there, so instead I'll move it to the top. It becomes just z to the 4th. Now here's another rule. If you raise a quotient to a power, meaning if you have a fraction, a over b, raised to the n, where a and b are any non-zero number, and n is an integer, you can basically just split it and say that it's a to the n over b to the n. Let's look at a couple examples. On the first one, if we have the quantity x over y raised to the 4th, that's just x to the 4th over y to the 4th. Split it, and both of them get the exponent. The next two are a little bit trickier. You get the quantity 3/2 cubed. Split it, and it becomes 3 cubed over 2 cubed. And I can simplify that. 3 cubed, 3 times 3 times 3 is 27, and 2 times 2 times 2 is 8. So I get 27/8. Now the next one already has exponents. I've got the quantity x squared over z to the 5th being raised to the 4th power. So I've got to multiply the exponents. Now if you weren't familiar with this rule, we'll actually cover it in just a moment. It becomes x to the 2 times 4 over z to the 5 times 4, or x to the 8 over z to the 20. If at any point I go too fast, just rewind the video and rewatch it. I've got to keep this video short for time's sake. Here we've got some that already have negative exponents. If you've got a fraction raised to the negative exponent, the easiest way to do this is going to take the reciprocal of the fraction and rewrite it with the positive exponent. So the quantity 3/4 raised to the negative 3 becomes 4/3 raised to the positive 3. Split it, and it's 4 cubed over 3 cubed. 4 cubed is 64, 3 cubed is 27. So it becomes 64 over 27. I can do the same thing with number 2, take the reciprocal, and it becomes the quantity m over 7a squared, or raised to the positive 2. Split it, and it's just m squared over 7 squared times a squared, or m squared over 49a squared. The next rule will be multiplying powers with the same base. If you have any powers with the same base, and these ones are both base a, which is any non-zero number, one's raised to the m and one's raised to the n, which are any integers, then a to the m times a to the n can be written as a to the m plus n. That means when you multiply powers, add their exponents. But you can only do this if the bases match. Here's a couple examples. 4 to the 5th times 4 to the 3rd can be rewritten as 4 to the 5 plus 3, or 4 to the 8th power. Now that's going to be a pretty big number, so I'm not going to simplify that out. I'm just going to leave it as 4 to the 8th. Try the next one. h cubed times h squared can be rewritten as h to the 3 plus 2, or h to the 5th. Now let's try a little bit harder one. Here we have expressions that have coefficients and powers. So if I have 3x to the 4th times 2x to the 5th, I'm going to group my like pieces. Those coefficients can go together, that's 3 times 2. And then I'll group the powers, x to the 4th and x to the 5th, and add their exponents. So I get 3 times 2 times x to the 4 plus 5, or 6 x to the 9. Here's a couple more problems. Pause the video, work these out, and then check your answers. I'll give you a moment. In the first one, we're going to group the coefficients. We get negative 2 times 5 times a to the 3 plus 4, or negative 10, a to the 7. In the next one, we go 4 times 3 times 1, or just 4 times 3, times d to the negative 3 plus 5 plus 2. That becomes 12. D to the negative 3 plus 5 is 2, plus 2 more is d to the 4th. So we get 12d to the 4th. In example number 9 here, we get the coefficients 10 and 3 together, and then the x squared and x to the 4th are like bases, so I get x to the 2 plus 4, and then I got y to the 6 times another y, which would be y to the 6 plus 1. Be careful, that y is a y to the 1, or 30x to the 6th, y to the 7th. In my last one, I got 7 times 2 times 1 times 1 for my coefficients, or just 7 times 2. K's are like bases, so that's k to the 6 plus 4, and m's are like bases, which is 3 minus 5. Simplifying, I get 14, k to the 10, times n to the negative 2. I have a negative exponent, so that m piece is going to move to the bottom. The 14 and the k to the 10 stay on top, and then it becomes over m squared. When you move it, make it a positive exponent. For our next rule, now we're going to raise a power to a power. If you have any non-zero number a with integers m and n, such that a to the m raised to the n, you'll do this by multiplying the exponents. This becomes a to the m times n. Let's look at a couple examples. In the first one, we have 6 to the 3rd raised to the 5th power. We're taking a power and raising it to a power, so this is just 6 to the 3 times 5, or 6 to the 15. Try example 2. Here we've got v to the 3rd raised to the 7th. This is just v to the 3 times 7, or v to the 21st power. Now here's 4 examples that are a little bit harder. In the first one, we've got the quantity 5x to the 4th, y cubed, all cubed. So what I'm going to do is split it and say that it's 5 cubed, x to the 4th cubed, and then y to the 3rd cubed, or y cubed cubed. So I'll rewrite it as 5 to the 3rd, x to the 4th cubed is x to the 4 times 3, and y cubed cubed is just y to the 3rd times 3, or 3 times 3. Simplifying this, 5 to the 3rd, 5 times 5 times 5 is 125, times x to the 12th, times y to the 9th. Try the next couple problems and then check your answers. Again, I'll give you a minute. Hopefully you've had a chance to work these out, so we're going to begin with the piece that has the exponent on the outside of the parentheses. So the d to the negative 15 for now will not change. We'll come back to that. We'll split the next piece and say it's 2 cubed times d to the 4th cubed, which is d to the 4 times 3. That becomes d to the negative 15 times 2 to the 3rd is 8, and then d to the 4 times 3 is d to the 12. Now we'll combine that d to the negative 15 and d to the 12. That's d to the negative 15 plus 12, or d to the negative 3. So I get 8d to the negative 3. Now that d piece has a negative exponent, so just the d piece moves to the bottom, and you get 8 over d cubed. For the third example here, the w to the 8 has an exponent on the outside of the parentheses, so we'll begin there. 7w to the 4th will not change initially, but the next piece becomes w to the 8 times 2, or w to the 16. Now we'll combine those powers. W to the 4th times w to the 16 is w to the 4 plus 16, and then the 7 in front. So we get 7, and then w to the, that becomes 20. The last example will begin with that x squared raised to the negative 3rd. That becomes x to the 2 times negative 3, or x to the negative 6. So I get x to the 6 times x to the negative 6, and when you multiply powers, you add their exponents. So 6 plus negative 6, or 6 minus 6, is just x to the 0, and anything raised to the 0 is 1. Now the last rule we're going to look at is dividing powers with the same base. When you divide powers with the same base, So for any non-zero number a with integers m and n, you're going to say that a to the m over a to the n would be the same as a to the m minus n. You subtract the exponents. So when you divide powers with the same base, subtract their exponents. Let's look at a couple examples here. In the first one, we have h to the 8 over h to the third. They have the same base, so I can say this is h to the 8 minus 3. 8 minus 3 is 5, so I get h to the fifth. Now the next one has coefficients. In order to do those coefficients, I need to reduce those. I know that 6 will not go into 9 and 9 does not go into 6, so I need to look for something that does. I know that 3 goes into both 6 and 9, so I'll reduce the fraction by saying that this is 3 times 2 over 3 times 3. The 3's cancel, and you get 2/3. So 6/9 reduces to 2/3, and then b to the 6 minus 2 becomes b to the fourth. So I get 2b to the fourth over 3. The last example just says d to the 4 over d to the 7, so I get d to the 4 minus 7. 4 minus 7 is negative 3, so I get d to the negative 3. However, I can't have negative exponents, so I'll put that as 1 over d to the third. Now there's another way to do this once you get good with it. Sometimes we'll just look at them and say wherever the bigger exponent is, top or bottom, is where the term ends up when you're done. So on numbers 1 and 2, I see the bigger exponent was on top. H to the 8 is bigger than h to the third, so the h's are on top. 8 minus 3 is 5, so I just get h to the fifth. In example 2, b to the 6 is bigger than b squared, so the b to the fourth is on top. But on example 3, the d to the seventh is bigger than d to the fourth, so the d's have to be on the bottom. 7 minus 4 is 3, so I could just go straight and say it's 1 over d to the third. And that's perfectly fine to do. If you recognize the bigger exponents on the bottom, just rewrite it where it's on the bottom, subtract the exponents. Alright, I hope this video helped you to understand how to do the power rules, and thank you for watching.